I am Blake Sanson.
Hello, I'm Caden Stone.
Hello, I'm Evan Spees,
and we are the Short Circuits. We created our robot because ocean pollution is a rising problem. One way we know that ocean pollution is a rising problem is, through research, we found that by the year 2050, there will be more plastic in our ocean than fish.
So the three main pollutants on oceans and beaches are cigarettes, food wrappers, and plastic beverage bottles.
O Robot can work under many circumstances, but it is mostly primarily designed to work on the open areas of sandy beaches. Right. That right there is the infrared sensor. There's a conveyor belt, and that's the collection bucket. Those two are tread protectors, and they help protect the treads from trash.
And here's where our robot finds the sorting station with the beacon.
So now that everything is powered off, the workers will take out all the trash and then they'll sort them, such as plastic and metal. So the reason our robot works so well is because of the conveyor belt and rake. So what happens is the conveyor belt and rake start at the same time as the whole loop, and then when the loop ends, the conveyor belt and rake go for an extra 15 seconds, and when those 15 seconds are done, a buzzer goes off.
Robot will go straight forward. Once it goes straight forward, it will turn and then go a short distance. It turns once again and goes straight down its path. Once it does that, it is in a loop for 2 times and will then move on to the next step.
We used an infrared sensor to find a beacon which is located at the sorting station. We added a range block because 0 was too narrow of a value, and it gave it a wider range for some wiggle room. And if it is in that range, the switch sets it to true, and it goes over here, and it goes straight at the beacon. If it ever gets out of the range, it sets to false, and goes down here, and will either go left or right, depending on where it last saw it. And then once the robot gets close to the beacon, up here it will break the loop, and then these 2 motors will stop. The robot stops.
Blake, why did you choose to use treads on your robot versus wheels?
Because treads provide better traction than wheels, and they stay on top of the sand instead of sinking in, and they have tighter turns.
Blake, what made you choose an infrared sensor on your robot?
It was the best way to get to our sorting station, because if we put a set path in, the robot could end anywhere on the beach and not always make it to the sorting station.
Caden, why does the conveyor belt never stop when the robot turns to go down the path?
When the robot turns to go down the path, the conveyor belt doesn't stop because then it will not pick up trash that's pushed away by the bumpers, and it will not pick up trash that is in the area of the turn.
Caden, why do you use the rubber band for the rake motor?
We use the rubber band for the rake motor because trash and animals could get stuck in the gears, but if we use rubber bands, they cannot get stuck. Rubber bands are cheaper to replace than gears, and if we used gears and something got stuck inside the gears, then it could burn out the motor. But if we used rubber bands and something got stuck inside, it would end up falling out and not burn out the motor.
Evan, why do you overlap the robot's paths?
The reason we chose to overlap the robot's paths was because once it moves, it may push trash just slightly out of the way. So when it turns, we wanted to make sure that we could pick up everything in its vicinity.
Also, how did you come up with the designs for the tread protector?
Well, we decided that after trash got stuck in the robot's treads many times, that we needed a way to protect the treads and not allow stuff to get jammed up in them.